Now we want to look at some other ions. We looked at monatomic ions, so those ions form from single atoms. Now we want to look at transition metals or polyatomic ions and see what types of ions are formed in those situations. So for our transition metals, we're talking about everything here in the middle of the periodic table. And what we find is that transition metals can usually have more than one possible charge. Again, when we talk about electronic structure later on, we'll see why this is the case. For now, we just want to know that it is the case, that they can have those multiple charges. So if we look at our transition metal ions, here are all the possible charges that we are going to see, and this is just the first row of the periodic table here. So we have scandium up through zinc, and what we see is that scandium and zinc each only have one possible charge, but everything else in between has multiple possible charges. Now some of them are more common than others, but the reality is that we can have a variety of charges, and it's for a variety of reasons. Now unlike the main group elements, which are very predictable in their behavior, transition elements are not quite as predictable. There's no way if I just say we have iron of you, an iron ion of you knowing which iron ion it is. We have to be given some additional information about its charge, about the number of protons and electrons, or about the type of compound it forms. So if we know what kind of compound it forms, we can kind of use a backwards logic to figure out what the charge is on that ion. And so silver is the only other example we have where there's only one possible charge. So silver, zinc, and scandium. And when silver we have a +1, zinc has a +2, and scandium has a +3. For these three elements, we only have one possible charge. And this is going to have some implications when we start looking at the nomenclature of ionic compounds involving transition metal ions. Now, polyatomic ions are a little bit different because we have multiple atoms here. That's what the expression poly means, is many, so many atom ions. And what it is that we have these ions that act as a group. For example, when we look at sulfate, SO4 2-, this charge doesn't belong to just these oxygens, it belongs to the entire ion. And so these atoms or these elements always act together as a group when we have a sulfate ion. Likewise with something like nitrate or carbonate. So these ions are this group. So imagine that group of girls in high school where everybody always stuck together. They never went anywhere by themselves. They always did everything in a group. That's what a polyatomic ion is. These atoms are not going to break apart. When we start looking at reactions with ionic compounds, we're going to see that the nitrate, for example, stays together when it goes from one atom to one compound to another. Same thing with hydroxide or ammonium. These are going to stay together as a group. So now when I start to look at forming a compound with these polyatomic ions, what I want to look at is the ion charge, just like I would look for a monatomic ion. So if I look at something like sodium and nitrate, okay, I can still do the exact same thing, do my crisscross down, and what I end up with is NaNO3. Now that gives me our compound. I have one sodium ion, one nitrate ion. We lost one electron. We had that negative charge from gaining an electron on the nitrate ion, and everybody's happy. The number of electrons lost equal to the number of electrons gained. Now, when I start looking at the polyatomic ions where I'm going to have more than one of them, I have to write things just a little bit differently. So if I look at an example of magnesium with, say, nitrate, what I find is that I can't have just one magnesium and one nitrate because I don't have a balance in charge. I'm not going to end up with an electrically neutral compound if I have a 1-to-1 ratio. I can do the same thing that I did before. I can look at my charges and make those my subscripts, but the way I need to write this is a little bit differently. Now, I need to write magnesium, and I'm going to have to use parentheses around that nitrate because what I need to say is that I have two nitrate ions here, not extra oxygens or just extra nitrogens, but I have two nitrates. I don't want to bring that 2 through and put N2O6 because that doesn't say the same thing as having two nitrates. But we don't want to use the parentheses unless we have to. The only time we have to use parentheses is when there's multiple groups multiple of these polyatomic ions, we need to put parentheses around it and use the subscript because that says we have two of those groups. So for something like magnesium sulfate, where magnesium has a 2 plus charge, magnesium has a minus 2 charge, I only have one magnesium and one sulfate, so I don't need to include parentheses there, much like I didn't need to include them here with the sodium nitrate. Now, for polyatomic ions, there's really no way around it other than memorizing these polyatomic ions. The best way to learn these is actually to do a lot of problems, but for most students, they're going to have to also do some memorization. This is a great time to use flashcards, whether it be electronic or paper, but just to get used to using those polyatomic ions. You need to know the name of the ion, you need to know the formula for the ion, and you need to know the charge on the ion.